So guys, this is the second chapter of time value of money. So let's solve this problem. Let's say we have a constant numbers starting by the second period and it has regular earnings, let's say, because it's allocated in the positive area. So we can say that we have a regular earnings started by second years. And we want to convert it, we want to make an equivalence. So we want to convert it into present conditions. So this regular cash flow is equal with the blah, blah, blah. So we want to find this blah, blah, blah or C by using a single payment. So we can consider this regular cash flow as a single payment. So we put our eyes to your left side. So in this case, all the cash flow can be viewed as future, right? So as a future. So let's calculate the first cash flow. So the first arrow, which is 100, and then count the steps to find out the exact number of end. Since the relationship is between the present and future, so I'm going to use the PF. Okay, just find present value if the future value is already mentioned, already given, already illustrated. So just like put 100 PF 50% to 2 is find by counting the step 1, 2. So we got PF 50% too. Now let's add to another cash flow, which is 100 PF, since it is located still in the future. Ask me today, we see all the cash flow as a future. Okay. Now PF still being used in this case because find that present value is future already mentioned 50%, and to calculate the step, just count 1, 2, 3. Put 3 on the end number, and then add to the fourth years. We have earnings as well, which is 100. We add 50% 4. Okay, 4 can be found by counting the step again. 1, 2, 3, 4. And the last earning is 100 plus still the same 100 PM 50% 5. 1, 2, 3, 4, 5. Can you see that every single cash flow can be calculated easily by counting the step and also just changing the point of view. Since we are in the present condition, so all the cash flow will be viewed as the future, right? So just calculate, just compute this formula and just multiply it by its compound factor. So this compound factor can be found in your compound table rate of interest. But I have a very quick formula. Since you know that single payment is easily, but you need more time, you need some time to solve the problem. We can view the regular cash flow as a single one, which is annuity. So annuity is just like putting the cash flow into one single payment, and the relationship is not just like the future toward present, but annuity toward present. So annuity is just like is applied for cash flow that has a constant number or has a uniform, has a pattern, has the same pattern, both for positive area or negative area, or earnings or disbursement you may also apply the annuity one. So let's continue the calculations. If we change the position into future ones, how about the equivalence? The equivalent is remain the same, but the number of period may have changed because we just switch our eyes to the right side. We switch our eye to the right side. It means the equivalent will be converted into your right. This is your new axis. Okay, since you are in the future, you may consider all the cash flow as your present or as your past, right? As your past or present. Now let's calculate the future value or just convert it all the cash flow into the future conditions. So it means when we view as a single cash flow, we have four present toward find out the future toward the present. So the formula will be find F. If P is already mentioned, have P something. Okay. Now the first one is 100. Why we put only 100? We don't put the exact compound factor since we want to know the exact value at the same period. So the same period we view as what is it? In the future value, we know that at the end of period convention, right? So it means we have to wait a little bit longer so we can know that the value may have changed. But now the observation taken in the same period, it means we can assume that the value might not have changed. So we can put the exact number, which is 100. You may neglect the compound factors for the same period or the same observations. Since the future value locates in the same cash flow, which is for 100, we may neglect its compound factors. It's only apply for the same observations, for the same questions in the same cash flow. And then we add another cash flow, which is 100 in the 4 years. So FP 50%, 1. Instead of using 4 as a number, we have to use 1 because this is our I, so we count the step just like this, 1 steps. Then put 1 as a number. Plus, we have still the cash flow for earnings at the 3rd years, 150%. And for the step, just count 1, 2. We put 2 as the number. And 100 still 100 FP 50%, 3. And don't forget to use a -1 for 2000, since we know that for -1 for the upward arrow, we use for disbursements. It means we spend some money, our money will be come out, will be taken, will be withdrawn in our bank account. So 2000 minus 2000 FP 50%, and then count the step. Just pull the step, just drag the position into our view, and then we go through 5 steps, right? So just put 5 as the number. So when we switch our point of view, the result may change, right? May have changed at all. And then don't forget that if the question locate, is located in the same cash flow, it means the cash flow itself we consider may stay the same or may have not changed. We can consider it as a constant number, and then we may neglect its compound factors, just like this. Now, actually, for those who has a pattern, a uniform pattern, can be viewed as annuity, like I mentioned you before. So we can apply to another compound factor.